This is a discriminants question taken from a C1 paper from May 2018 provided by Edexcel. 2 parts, each worth 4 marks. And I've chosen this question specifically because you start with this quadratic, which is not given in the usual format. You've got x squared terms on both sides of the equal sign, and you've also got this constant k, which does trip students up quite a lot. So we're given the equation 20x squared equals 4kx minus 13kx squared plus 2, where k is a constant, has no real roots. And in part A, we have to show that k satisfies the inequality 2k squared plus 13k plus 20 is less than 0, and that's for 4 marks. So what I'm going to do is start by rewriting this quadratic. And I'm going to, first of all, add 13kx squared to both sides. Subtract 4kx from both sides, and then subtract 2, and that's going to be equal to 0. I do this because this is the standard way to solve quadratics. We get one side equal to 0, and what I'm also going to do is tidy up the terms, or the x squared term, so that I can see the coefficient of x squared, the coefficient of x, and then the constant that's on the end in the usual way. So it's just this k that makes things slightly horrid looking. If you're completely uncomfortable with this, you could always choose a value of k, say k equals 1 to start off, and see what happens, but do make sure that you go back to treating k as an arbitrary constant when you actually answer the question. So we're told that this equation has no real roots, so this is a discriminants question. So let's just recap what we know about discriminants. So if I'm given this equation and I'm told that there are no real roots, then I know that the discriminant, which is b squared minus 4ac, should be less than 0. Okay, if we're told that there's one repeated root, then the discriminant is equal to 0. And if I'm told that there's two complex roots, then two real roots, then the discriminant is positive. But I know this to be true, so what I need to do is look at what a is. So in this case, a is 20 plus 13k, i.e. the coefficient of x squared. Look at what b is, the coefficient of x, which is minus 4k. And look at what c is, which is the number on the end, and that's a minus 2. So b squared would be minus 4k squared. I'm taking off 4 lots of 20 plus 13k multiplied by minus 2, and I know that that whole expression should be less than 0. So let's tidy that up. 16k squared, I've got plus 8, because I'm multiplying minus 4 by minus 2, positive 8 multiplied by 20, and positive 8 multiplied by 13k, so 13 times 8 is 104, and that's positive. And then 8 multiplied by 20, which is plus 160, and this should be less than 0. Okay, so each of those terms have a common factor of 8. So what I'm going to do is divide both sides by 8. I'm allowed to do that on inequalities. 8's a positive number. It doesn't affect the direction of the inequality. So dividing both sides by 8 will leave me with 2k squared plus 13k plus 20 is less than 0. Okay, so let's just have a little look at the that is exactly what we were supposed to do. Part A completes because we have showed that k satisfies the inequality as shown. Now, in part B, we have to find a set of possible values of k. So this question is broken up slightly so that, it gives you an idea of what to do first. You don't have to do it all in one go. That's probably because they've given you this nasty looking quadratic to begin with. So in part B, we have to solve this inequality. So let's have a look at factorising. So in order to factorise this, assuming that you can factorise it, I know that we can, I need to put 2k in the first bracket and k in the second bracket in order to get this 2k squared term. Now the numbers that go here and here must multiply to make 20, but have to be chosen in a specific way so that you get a 13k when expanding. I know they're both positive, everything's positive, and I just so happen to know that I need to put a 5 here and a 4 here, because when I expand this, I'll get a 5k and an 8k, which add together to make the 13k that we require, and it also gives me my 20 as required. Now, the easiest way to find the k values for which this is true is to plot this new quadratic on some axes. So whereas before we had y against x, we've now got y against k. So this is not the original quadratic. So this is not that original quadratic. It's a new quadratic we found by setting the discriminant of that quadratic to be less than 0. So what are the roots of this quadratic? So where does the quadratic equal 0, not less than 0? So this occurs when k is equal to minus 5 over 2 or minus 2.5, or when k is equal to minus 4. So minus 2.5 minus 4, let's put those there for argument's sake. And it's a positive quadratic because when we multiply out these two terms, we get a 2k squared. So it's the shape like so, and it'll cross the y-axis somewhere. Just pop that there for argument's sake. And so I can see now this quadratic is below the line when k is between minus 2.5 and minus 4. So minus 4 is less than k, which is less than minus 2.5. This is where the curve is negative. So the answer to part B, find the set of possible values for k, is k between minus 4 and minus 2.5. And that concludes the question. So check out studywell.com for more.